5th, please. Okay, here we go. So again, today, you all saw my email with a very detailed schedule of what's happening for the next 3 weeks till the break. So I'm going to talk a lot today. Tomorrow, you're on your own working on this. And it's due on Friday, so it is what it is. Okay, here we go. So today, we want to sort of move to like the next, are we on?
Yeah.
So we want to move to the next phase, which is going to be, we give you a graph without multiple choice answers, and we need to come up with an equation. On the Thanksgiving homework, those who did it, there were questions where we gave you a graph and answer choices. And I made videos on a few of those problems, as you know. But today we want graph, no answer choices. We write the equation. Now, before we do that, we need to remember a few things. And the first thing is, let me draw. I actually don't need this paper. Let me draw right here. Let me draw this. Y equals sine of x. And we have some point here 1, some point here -1. I was really excited, folks, for my Black Friday purchase.
Wait, where?
At Walmart. I saw Miss Pandia there. It was super cool.
Where exactly?
The Walmart in Meyer, Bill, right here.
Oh,
Right here on Meyer Park.
that doesn't help get over that.
All right.
You
Now,
should put it
Fairleft? Okay. The next graph. All right. Here's the next graph I want to draw. Y equals negative sine of x. So let me draw negative sine of x. So in blue we have regular sine. In green I'm going to draw the negative sine. And now let's go ahead and map these two functions. By the way, their map will be the same. Let's go ahead and map them. And here's my midline. I'm trying to hash in that midline in gray. Hash in the midline in gray. All right. Now let's notice something. This is crucial, folks. This is very crucial to notice. When you think about the sine graph starts at the midline and goes up. Sine graph starts at the midline and goes up. Negative sine does also start at the midline, but goes down. Notice the difference. It's not that it starts at the origin, that just happens to be the case. It starts at the midline. The midline here is y equals 0. The midline where y equals 10, the graph would just be moved up. But the key point is, sine graph in blue starts at the midline and goes up. I'm going to write that down. Y, like point number 1, y equals sine of x starts at the midline and goes up. Whereas negative sine, I'll do that over here, number 2, y equals negative sine of x starts at the midline and goes down. This is going to be crucial to know. These two facts will become very helpful as we write these equations. Any questions on sine? All right. Let me go to cosine. Y equals cosine of x. And then in purple, let me draw y equals negative. And then go ahead and map the two functions, please. Let me pause here to let people catch up and see if there are any questions. Okay, let's notice something. Y equals cosine of x starts at the maximum and goes down. Y equals cosine starts upstairs and goes down. Y equals negative cosine starts at the minimum and goes up. Those are going to be very key properties. Let me write those down. So number 3 was that y equals cosine of x starts at the max, and I mean, by definition, if you start at the top, you got to go down. But I'll write it in there. It goes down. Whereas number 4, y equals negative cosine of x starts at the min, and by definition, right, goes up. All right, so any questions on this? Okay, these 4 pieces of knowledge will be crucial as we write the equations of periodic or sinusoidal functions. Sinusoidal just means either sine or cosine. So let's do some examples. So now we want to go to the handout you picked up. Let's go to problem 1. Now, the directions might be a little bit unclear, so I want to clarify those now just so we're all on the same page. The directions for part 1 say write an equation using sine and cosine for each of the functions. That's a little bit misleading. It should say write one equation using sine for this graph, and then write another equation using cosine for this graph. So you're going to write 2 equations for each one. If you need to correct the directions, feel free to do that so you know what we're asking. Now, a very important point. Yeah. Can I repeat it? Yeah. So for every graph, you want to write 2 equations, one of them using cosine and one of them using sine. And there's an important thing to remember here. Every periodic function can either be written with cosine or with sine. Let me repeat that. Every periodic function can be written either with sine or with cosine. Okay? In other words, there are multiple ways to write the equation of this graph. And let's go into how to do that now. All right. I'm just so excited to try out all these colors. All right. This might not be readable. Let's find out. Step 1, map this out. Step 1, we need to map it. Is that readable? Yeah, it's good. So let me map this out. And many of you are able to do this on your own. If you are, go ahead and try it. Those who need to look up here, feel free to. Some may want to look up here only to check. So let me stop here, midline and amplitude. Any questions on midline and or amplitude? So the next thing we need to find is period. Here's the way I always find it. I think what what I believe to be one of the best ways. Start here at 0. We know a period or one cycle has to have a max and a min. So we start here, come up to the max, down to the min, back to where we started. So the period is from here to here. How much is that? That's from 0 to pi. So what is the distance? Now, we need to find b also. Remember, b is the frequency that's helpful in our equation. This is the period. The b value is not the period. The b value is not the period. Yes, I'm banging on this. I want to illustrate this point. We tried to make the point last year and people missed the common assessment question. I was upset that I didn't make the point well enough. The b value is not the period. The period is pi. Then I need to find b. Why do I need to find b? Because remember, I'm writing this equation. Remember, this is the equation I'm writing. A amplitude, M midline, C is the shift horizontally. But B relates to the period. B is called the frequency. It's a physics term. You should ask Tarek about it. So how do I find B? Well, we know that 2 pi over B equals the period. So let's use that formula. 2 pi over B has to equal pi. Solve for B. All right. I want to stop here before I go on and see if there are any questions on mapping. Because I want to get to a point where like the mapping is just like this, super quick. And I'm going to try to get there, but I want to make sure everybody's all right with this. Okay. Now that the function is mapped, I know what A is, I know what B is, and I know what M is. I'm going to write this equation without the A, B, and the M filled in with the correct numbers. You all can try that before I do it. Why don't you try that before I do it? I'm going to do it on a new sheet of paper because I don't have enough space here. All right, here's where I am. Here's where I am. Now, we just need to see if there has been any shift. Here's the way to do this, folks. And this is going to be hard. We will make mistakes. That's why we have a lot of practice. That's why you're doing this all tomorrow. The way to think about it is the following. We know from the previous discussion that sine always starts at the midline. We know that sine always starts at the midline. Let me draw the midline in here. Sine always starts at the midline and goes up. Let's look at this graph. This graph starts at the midline and goes up. There has been no shift. We are starting where we are supposed to start. Let me repeat the logic here. Sine graph is supposed to start at the midline and go upstairs. Our graph starts at the midline and goes upstairs. There has been no shift. We are starting where we are supposed to start. Let me stop and take questions. David.
That means C is 0.
That means C is 0. Oh, sorry. Oh, Salma, sorry. So in this case, C would be 0. So we have Y. So our final equation is the following. So Marcus. Now, We could also write an equation using, instead of positive sign, I'm going to write one using negative sign. So I'm going to write this equation using negative sign instead of positive sign. So it's going to be y equals negative a sine of b x plus c plus m. So instead of positive sign, I'm going to have negative sign. Okay. Give me a couple minutes. Now, I'm just going to use negative sign instead of positive sign. But nothing has changed from the graph, which means the amplitude is still 4, the b value is still 2, and the midline is still 3. Nothing has changed about the graph. It's just a different way of writing the equation of the graph. So in other words, I know it will be something like this. The amplitude still has to be 4. The graph hasn't changed. The b value still has to be 2. Graph hasn't changed. Shift might be different. And the midline has not changed either. So the question now is, what, if any, shift has happened? And here's how we find the shift. We think about negative sign graph. We talked about this right before. We said the negative sign graph starts at the starts at the midline and goes down. You see the notes. Negative sign starts at the midline and goes down. So we should start right here. We should start right here. Right? The graph should have started there. Midline and then down. But there has been some shift. In other words, we have shifted this way. This should have been there. But it has been shifted. Which way did we shift? Well, it should have been here, so we moved it right. And how much do we move it by? Whatever this is. Pi over 2. So how am I going to write this? I'm going to write y equals negative 4 sine 2. And here comes the shift. Because I shifted right, I need a minus sign. And how much did I shift by? Pi over 2. Jose Oliva.
Wait, does it matter how much you shift by? Like, as long as it's going down? Like, can it be any number for C as long as it's going down?
Yes. So you could have picked this one too.
Okay.
Yeah. Fabrizio.
But if it's negative, you don't need to shift because the thing flips over.
No. Well, okay. So negative sign means that we start at the middle and go down. Right? So this point should have been where we started. Start at the middle and go down.
Okay.
Right? That should have been where we started, but we didn't. Right? The graph was moved a little bit. And the graph moved right by pi over 2.
Oh, okay.
Okay, Carla. Yeah, I mean, if you want to use this point, so you could have written plus pi over 2. In this case, it would happen to work. I think it's better to just always focus on this side, but if you want to do that, then it's fine. If that did not make sense, don't worry about it.
I'm still kind of confused on why you used the point pi over 2, column 3.
Mm-hmm. Right, because I wanted the sign graph to start at the midline and go down. So here's the midline going down.
And that's the first point on the midline that you get to.
That's going down.
Okay.
Because here we're at the midline, but we're going up. But here's midline going down. So I'm going to pick that point, right? And that should have been there. So what happened? Well, this moved over. How much did it move over by? It moved over by pi over 2 to the right. Ginny. For a negative sign, absolutely. Yeah, absolutely. Okay. Now, we need to do the same process for cosine. Okay. Let me go ahead and do that. Marcus, what's up? Speak to me as I do this in hushed tones. Or you want to watch your writing? So, for cosine, we know we want an equation that looks like this. we definitely want this. Now, if we want this, we already know this. We already know this, and we already know this. Let's fill those in. Let's fill them in. We already know what they are. The graph hasn't changed. I already know what they are. The A, B, and the M aren't going to change. The picture hasn't changed. They can't change. They're based on the picture. Now the question is, how much of a shift have we had? Cosine is supposed to start at the maximum. Cosine is supposed to start at the maximum. So that point right here should have been there. But it's not. It was shifted right. How much was it shifted right by? What's halfway between 0 and pi over 2? Pi over 4. So we shifted right by pi over 4. So we have y equals 4 cosine. The 2 stays. X shifted right by pi over 4. There you have it. Questions?
Is it okay we leave it as plus or minus pi over 4?
Okay. I think what you're saying is it okay if you write it like this? Is that what you're saying?
I think
The
the
minus
plus and the
one.
minus and lead to plus.
No. You can have it like this with the minus there. That's fine, but not here. No. Either of these bottom two are fine. They say the same thing. Questions? Now, instead of using positive cosine, let's do this using negative cosine. So negative cosine, some things aren't going to change. You should be able to fill in already what will not change. Yeah, so why don't you get a copy on shelf 1? Is it not on 3? It should be on 3. If it's not on 3, then we'll find another spot for it. And just make sure that your classmate will vouch for that. I mean, I'm sure it is true. I just want to make sure. Okay, so here we have this much stays the same. And I just need to find out what is the shift. I just need to find out what is the shift. Well, negative cosine starts at the minimum. Negative cosine starts at the minimum. So this point should have been here. But it's not. Somehow the graph has shifted right. And how much have we gone right by? Somewhere between pi over 2 and pi. What's halfway between pi over 2 and pi? 3 pi over 4.
Dang it!
Halfway between 90 and 180 is 135.
I got 2 pi over 4. That was close.
All right, so our final answer. Jasmine, and we'll come back to Lynn.
Can we solve this kind of problem for the homework? Do we need to have all 4 answers?
You pick one sine, one cosine. I'm just showing you that it can be written as all 4. Rafa, then we'll come. Sorry, Rafa.
Oh, so the first one you could also do it the other way, and instead of doing that, you could add plus pi over 4.
Yes. Jose Oliva.
No, I'm good.
Okay. All right. Let's go to number 2. All right. So number 2. Here we go. Again, I'll do it on a separate sheet. I'll move a little quicker. Some of you might be able to do this problem on your own. Jump right in. Don't need to wait for me. I'll move at a little bit quicker pace, but stop me if there's a question. Step 1 always is mapping. So everybody should be doing number 2. If you've already done it, obviously keep going. Stop me with questions, though. I'm going to start with the two sign versions, positive sign and negative sign. Let me write a separate sheet of paper. So here's what I have for sine. Here's sine. David Torres.
Like since it was one, I didn't put the.
You do not have to write this or this.
Oh.
If you do, it's fine. If you don't, that's fine too. Because you're multiplying one. Need to have this one, of course, here outside, because we're adding. So here's the positive sign. Let me take questions on that. And now I'm going to do the other three. Negative sign and the two cosine ones. Those folks who are good, keep on going. Do not stop. Negative sign is on the board. I'm moving to cosine. Any questions on sine or negative sign before I go to cosine? David Torres.
How'd you get minus 2 pi? I mean pi over 2.
Here?
Yeah.
Bart.
Wait, boss.
Barca.
Why is it minus pi over 2?
Because we shifted right. So you do the opposite of what it says?
So we add, but then wouldn't that make it negative sign?
No, because, so for right here, we have this point. Carl, I'll get to you in 1 second. We have this point here. This point should have been here. So where is it now? It's shifted right. How much did it shift right by? Pi over 2.
Oh.
Carla? Yeah. Let me go to cosine. Here's cosine. And the last one, negative cosine. All right, let me stop here before we go to the next one.
How do you get 3 pi?
It's the same thing as pi.
Oh, yeah.
Okay, so let me take questions now. Carla? Right here? Yeah. Yeah. So for those who are good, I'm going on to page 3 on the Ferris wheel problem next, but I'm going to take another minute to let other folks catch up. But that's where we're going next. Let me wait here, see if there are any more questions. You need to make one correction on the Ferris wheel problem. Again, if you're not there, not to worry, no need to rush. On the Ferris wheel problem, it should not say assume car E starts at the top. That was a misprint. I apologize. On the Ferris wheel problem, it should not say assume car E starts at the top. Last line of part A.
Were you seeing the graph backwards when you wrote it?
No, before I didn't have a picture, so I was like, let me just put it at the top. But then I said I'll be nicer and give him a picture. So. Are there any more questions on what's on the board here, writing the equations before I go to Ferris wheel? All right, let's jump into Ferris wheel problem. All right. I'm going to draw the graph on a separate piece of paper because that gives me more space. It says that the center of a Ferris wheel is 80 feet above the ground. The radius is 60. The Ferris wheel takes 4 minutes to make a revolution, and it's moving counterclockwise, so we're going this way. Sketch a graph which relates the height of car E for the period from 0 to 12, and we're going to scratch out the assume it starts. Okay. So let's draw our graph. We'll call this time in minutes. And we'll call this one height in feet. Now, at time t equals 0, we need to see how high off the ground is E. Well, let's use some logic here. This distance from here to the ground is 80. This radius is 60. So how far off the ground is E?
20.
Very good. Now, if car E is 20 feet off the ground at time equals 0, when is car E back to 20 feet off the ground? T equals what? When does it return to that spot?
Every 4 minutes.
Every 4 minutes. 4, 8, 12. So every 4 minutes, we are at 20. Now the question is, when do we reach our maximum height? Well, the maximum is going to be right here. Now, how tall is that? Well, this was 80 was the gray spot. 80 was the gray point. This right here is 60. So in total, how high off the ground is A?
140.
140 feet. And when will car A reach 140 feet? Osnari? I cannot hear you. I cannot hear you. 12 what? I cannot hear what you're saying. At 12 minutes, it's down here at 20. We're asking, when are we going to reach 140 feet? I cannot hear you. I cannot hear you. Hold on. Oh, sorry, what? I cannot hear you. Oh, you're not saying anything. Okay. So when are we going to reach 140 feet? Okay, so I agree with you. Some point between 4 and 8. Let's focus on this first interval between 0 and 4. When will we reach 140 feet between 0 and 4 minutes? To what? Why? Why should it be exactly between 0 and 4 though? I don't know. Should it? I don't know. Use some logic. Logic. Wait. Logic. If at 0 minutes I'm here, how do I know for sure? Oh, sorry, we're still with you. How do we know for sure it's going to take 2 minutes to go up here? I appreciate that you're on the correct page. No, but you said at 2 minutes. Why did you say 2 minutes? Well, why? Why should it be half? Why should it be half? Think logically. Why should it be half? If I start here at 0 minutes and it takes 4 minutes to get back here, why is it 2 minutes at the maximum? Why is it exactly halfway between it? Yes, there we go. Now we're making some progress. We're only going half a revolution. The other way to say it is if we start at the minimum and it takes us a certain amount of time to get back to the minimum, it must take half of the time to get to the maximum, or vice versa. If we start at the maximum, it takes us half the time to go halfway around the circle. Half of the revolution. Another way to think about it, there are 8 spots here. 1, 2, 3, 4, 5, 6, 7, 8. 4 minutes to go all the way around. Each chair is 30 seconds. 30, 1 minute, minute 30, 2 minutes. So 2 minutes to go all the way to the top. When will we be back all the way at the top, Irene? 14, but it's telling us to stop at 12. 10 minutes, and where else? 2, yeah. So we got at 2. Hosnari got us that one, and now you're saying 10, and where else? 6. And why are you saying these points? Okay, that's one way of saying it. How could I use the period to make my explanation, Irene? It is half of it. That is how, yes, I agree. That's how we get the 2 minutes. And yes, halfway between 4 and 6, between 4 and 8 is 6. But how could I have known right away that I'm going to be there at 2, 6, 10, 14, 18, and so on and so on? How do I know? What does the period mean, Irene? Good. What do we mean by revolution? Whoever's phone is going off, can you give me that? Keep going. So what do we mean by the time to complete a full revolution? What does that mean? What does a revolution mean? Okay, good. A complete circle or cycle. So it takes me 4 minutes to complete a cycle. Now, how does that relate to the 2 and the 6 and the 10 and the 14? Every 2 minutes? No, but you're saying every 4 minutes. Because you said it happens at 2 minutes, and then at 6, and then at 10. Why does it happen every 4 minutes? What do we mean by period? What did you say the period meant? Good. The time it takes to complete a cycle. So 4 minutes later from here, I will have completed a cycle, which means I will be back to where I started, i.e., I'll be back to the maximum. 4 minutes later, I'll be back to the maximum. 4 minutes later, I'll be back to the maximum, and so on.
Vice versa.
Vice versa for the minimum. And then you simply connect the dots. Expect more of the Socratic method of me calling on people individually. Expect more of that. Now they want us in part B to find the midline, amplitude, period, max, and min. Let's go for that. Many of us can do this on our own. We should be doing that on our own.